Welcome to Fluid Mechanics and Hydraulic Machines Laboratory. Today we are going to conduct an experiment on calibration of rectangular notch. The aim of this experiment is to determine the coefficient of discharge of a given rectangular notch. Notch is an instrument which is used to determine the discharge over a open channel. There are different types of the notches based on their shapes. It can be classified as rectangular notch, triangular notch, V-shaped notch, trapezoidal notch and Cipolliti notch. Coefficient of discharge can be calculated by knowing the theoretical discharge and the actual discharge. The theoretical discharge depends upon the head present above the crest point in a notch. The actual discharge can be calculated by knowing the time taken for a 0.1 meter raise or 10 centimeter raise of water level in a collecting tank. This is the experimental setup of a rectangular notch. Rectangular notch is a steel plate which is fixed to the approach channel. The water is pumped to the approach channel from a source. At the outlet of the notch, the water is collected in a collecting tank of known area. Before conducting the experiment, measure the length of the notch through a scale. Firstly, switch on the pump and allow the water to flow through the approach channel. The water flowing above the crest is called as nappe. After a steady flow is attained inside the approach channel, measure the head present above the crest level using the pointer gauge. The sharp edge of the pointer should not be immersed inside the water level. It should touch the surface level. Note down the main scale reading and verniers reading in the pointer gauge to measure the head above the crest point. Close the outlet of the collecting tank and note down the time taken for a 10 cm raise of water level inside the collecting tank. Conduct 2 to 3 trials with varying discharge conditions to determine the average coefficient of discharge. The observation and calculation part in calibration of rectangular notch is: first, note down the breadth of the collecting tank, which is taken as 0.3 meter. The length of the collecting tank is 0.3 meter. Therefore, the area of the collecting tank is the product of breadth and the length of the collecting tank, which becomes 0.9 meter square. The theoretical discharge through rectangular notch is given by the formula Q theoretical is equal to 2 by 3 into square root of 2g into L into h to the power 3 by 2, where L is the width of the notch, which is taken as 0.075 meter, that is 7.5 centimeters the width of the notch. We are going to write in terms of meters. H represents the height of water surface above the apex of the notch, or we can also say it is the head above the crest point in a rectangular notch. The head of the water above the crest point with respect to a rectangular notch is calculated by the formula H is equal to H1 minus H2, where H1 is the head with respect to the crest point and H2 is the head with respect to a full flow condition. While note downing the H1 value with respect to the pointer gauge, we are going to measure the main scale reading and the vernier scale reading. With respect to H1, the main scale reading is taken as 17.2 cm and the vernier scale reading is 4. The formula used to calculate the total height is MSD plus VSD into least count. The least count with respect to point gauge is 0.02. The main scale reading will be in terms of centimeter convert it in terms of mm. That is 17.2 centimeter becomes 172 mm. The VSD, that is the vernier scale reading, is 4. Multiply that with respect to the least count. Therefore, H1 becomes 172.08 mm. H2 is the head with respect to flow condition. By using the above formula, when we calculate, H2 becomes 145.52 mm. Therefore, the head above the crest point is given as H1, the difference between the head with respect to crest point and the head with respect to flow point. Therefore, H is equal to 172.08 minus 145.52, which is 26.56 mm. Q theoretical with respect to a rectangular notch is given by 2 by 3 into square root of 2g into L into h to the power 3 by 2, where L is nothing but width of the notch, which is taken as 0.075 meter. Therefore, when we substitute the values in the equation, the head with respect to the flow condition is 26.56 mm. We have to write in terms of meters. Therefore, the Q theoretical is going to be 9.586 into 10 power minus 4 meter cube per second. The Q actual with respect to a rectangular notch is given by the formula A into R by T, where A stands for the area of the collecting tank, which is taken as 0.9 meter square, and R is the raise of water level in the collecting tank, which is taken as 0.1 meter. For the 0.1 meter raise, the time taken was 12 seconds. Therefore, when we substitute these values in the equation, the Q actual value becomes 7.5 into 10 power minus 4 meter cube per second. Coefficient of discharge is given by the ratio Q actual by Q theoretical, where Q actual is 7.5 into 10 power minus 4 and Q theoretical is 9.586 into 10 power minus 4. Therefore, the coefficient of discharge with respect to a rectangular notch becomes 0.78. For the various discharge condition, calculate the H value and determine the coefficient of discharge, and finally determine the average coefficient of discharge for a rectangular notch.